everyone, welcome back to Why Decrypted. Today we are doing the Fermi Paradox, and I think this is our second script on this. So let's open with the puzzle. Picture this, the universe is ridiculously big. Astronomers estimate about 2 trillion galaxies. Each of those galaxies contain billions of stars, and around many of those stars are planets. Not just a handful, but potentially billions. That's billions of worlds scattered across the cosmos. If even a fraction of those planets are Earth-like, then statistically, life should be everywhere. Civilization should be buzzing across the universe like intergalactic Wi-Fi. Starships should be roaming about between systems, signals flashing back and forth, the galactic neighborhoods full of chatter, and yet what we see is silence. No friendly neighbors calling, no mysterious spacecraft cruising by. Not even a cosmic postcard saying, "Wish you were here." And this puzzle has the name, the Fermi Paradox. The question is simple, but unforgettable. If the universe is so vast, and life is so common, then where is everybody? This isn't a new thought experiment. The paradox dates back to 1950, when physicist Enrico Fermi was at lunch with colleagues. They were joking about UFO cartoons in the newspaper, and in the middle of that laughter, Fermi suddenly asked, "But where is everybody?" It was a moment of clarity. If the galaxy is full of stars, many are older than our sun, then some civilizations should have millions of years to advance. Enough time to cross the stars, settle planets, or at least make themselves visible. And yet here we sit, apparently alone. Since that lunch in 1950, the Fermi Paradox has been haunting scientists, philosophers, and late-night internet forums alike. So most discussions of the Fermi Paradox work from one hidden assumption. That humanity is typical, we're normal, the baseline. So the problem must be them. Why don't we see aliens? Well, maybe the distances are too big. Maybe civilizations wipe themselves out before they can spread. Maybe they're hiding. Or maybe life is so rare that we're the only ones. So let's slow down and look at these classic answers. Number 1. The universe is too big. Life might exist out there, but the distances are absurd. The nearest star system, Alpha Centauri, is over 4 light years away. That's 40 trillion kilometers. At current spacecraft speeds, it would take tens of thousands of years to get there. And that's just our next door neighbour. Zoom out to the whole galaxy and the scale is crushing. You could scatter needles across an entire continent and it would be easier to find them than it would be for 2 civilizations to bump into each other in that void. So maybe we don't hear from anyone else because nobody is close enough. We're just yelling into an endless desert. Option number 2, the Great Filter. This one is darker. It suggests there's a bottleneck in evolution or civilization that almost nobody survives. Maybe life struggles to get started at all. Or maybe it's easy to get as far as we have, but almost impossible to go any further. Civilizations might be fragile by default. Nuclear war, ecological collapse, rogue AI, asteroid strikes, pandemics, take your pick. If the Great Filter is behind us, that's actually good news. It means the leap from single-celled life to complex organisms is so improbable that Earth really is special. We've already beaten the odds. But if the filter lies ahead of us, then the silence in the galaxy is a warning. It means advanced civilizations don't last very long. Option number 3, the zoo hypothesis. This one is oddly flattering. Maybe aliens are here, but they're deliberately hiding. We're like animals in a cosmic safari park, watched but not interfered with. They're waiting for us to grow before revealing themselves. It's a neat idea, but also a bit too neat. If advanced civilizations are common, why would every single one agree to keep the secret? How do you run a tidy zoo across the galaxy? Option number 4, we're alone. Maybe life itself is vanishingly rare. Out of all the planets, all the stars, only Earth won the lottery. That makes us unique, but also terrifyingly fragile. If we're the only intelligent species, then we carry the full weight of consciousness in the universe. So these are the classic 4 theories and the classic 4 answers. But notice something. They all assume that we're the normal ones, that we're just a standard civilization, scratching our heads because the others aren't showing up. What if that assumption is wrong? What if we flip the script? What if the real paradox isn't that aliens are absent, but that we exist at all? What if humanity is the strange case, the unusual outcome, the statistical outlier? Think of it like this. If you walk into a room of 1,000 people and everyone is quietly reading, but one guy is standing on a chair yelling into a megaphone, you don't ask, why is everyone else so quiet? You ask, why is that one guy so loud? What if we're that guy? Instead of asking, where is everybody? Maybe the deeper question is, why are we so unusual? So this brings us on to our biology. We start with the building blocks of life. On Earth, the recipe feels obvious. Carbon-based chemistry, water as a solvent, DNA to store information. Life seems inevitable in hindsight. But that's hindsight bias talking. We don't actually know how life began here. We have good theories, warm little ponds, hydrothermal vents, lightning sparking chemical soups, but we can't recreate it from scratch. Abiogenesis, the leap from non-life to life, is still a black box. For all we know, that leap is almost impossible. Maybe it took a freak accident of chemistry, and it only happened once in the entire galaxy. If that's true, the microbial slime might be uncommon, but the path to complex thinking animals could be 1 in a trillion. Even after life began, look at how many lucky breaks were needed. The jump from single cell to multicellular organisms. The explosion of complexity in the Cambrian period. The asteroid that wiped out the dinosaurs, clearing the stage for mammals. At every step, there were dice rolls. Some we won, and some we only survived by chance. If you run evolution again on Earth, it's doubtful you'd get humans twice. So maybe most planets are full of bacteria, oceans of slime, deserts of microbes, swamps of single cells. They might thrive, they might adapt, they might persist for billions of years, but they never build telescopes or wonder about the stars. That would make us unusual. The loud kid in a galaxy of silent ponds. And even if evolution does throw up complex animals, there's no guarantee they'll develop high intelligence. Dinosaurs dominated Earth for hundreds of millions of years without needing laptops. Crocodiles, jellyfish and sharks are perfectly successful without philosophy or mathematics. I like the fact, Ben, you're assuming that we're highly intelligent. In our sense of the word, intelligence might be a weird side quest and not necessary for survival. So maybe big, self-aware, tool-building brains are actually maladaptive, costly to run, prone to anxiety, vulnerable to overthinking. Most ecosystems never stumble into this niche at all. In fact, there are arguments that our intelligence is maladaptive. Yes, it helps us dominate this ecosystem, but it also drives us to war, environmental collapse and self-destructive technologies. Other species might thrive precisely because they don't overthink everything. So maybe most life never produces tool-building, self-aware creatures. Maybe they never make YouTube videos. Maybe intelligence as we define it is vanishingly rare. In that case, the paradox flips again. The silence in the stars isn't mysterious. It's exactly what you'd expect in a universe where most life is simple, content, and not obsessed with asking cosmic questions. In that theory, we're the weirdos, the galaxy's oddballs. The ones who just can't stop poking at the mystery. Okay, so suppose biology isn't the main issue. Let's imagine that life does manage to crawl out of the slime, evolve into complex creatures, and even build technology. That still doesn't mean we're typical. Because here's another way we might be weird. We might be weird because we shout. For the last century or so, humans have been unintentionally broadcasting their existence. Radio signals, radar, satellite transmissions, television shows, mobile phones, all of this leaks into space every day. Our planet sprays electromagnetic noise into the galaxy. It started innocently. The earliest radio signals from 1920s are still expanding outwards, a faint bubble about 100 light years across. Within that bubble there are thousands of stars. If someone had a sensitive enough receiver, they might have picked up a snippet of early broadcasts. And what would they hear? Scratchy jazz, news bulletins, political speeches, and then later sitcoms, adverts, sports commentary, the raw noise of human culture. To us this feels normal. But what if it isn't? What if most advanced species don't do this? Imagine a galaxy where the etiquette is to stay quiet. Civilizations communicate with tight beam lasers, fiber optics, or some technology that we can't even imagine. Methods that don't spill into space. Maybe they're cautious by design. Or maybe they've learned the hard way that broadcasting your location is a bad idea. If this is the norm, then Earth is the oddball. We're the neighbours who leave the curtains open and shout about football scores. From their perspective, we're noisy, undisciplined, maybe even reckless. And that would help explain the silence. Everyone else is whispering. We're the only ones yelling into the void. And this can bring us on to the timeline problem. The universe is around 13.8 billion years old. Our solar system is about 4.5 billion years old. And humanity, as a technological civilization, has existed for one blink of an eye. Barely a century of electronics. A few thousand years of writing. A couple of 100,000 years of Homo sapiens. That is nothing on a cosmic scale. Maybe the reason we don't hear anyone else is simple. Timing rarely lines up. Civilizations could be common, but they rise and fall millions of years apart. One species flourishes, explores a bit, then collapses. Millions of years later, another one rises up on another planet, but they never overlap. Ships passing in the night, except the night lasts for geological ages. But what if our timing isn't just unlucky, but also strange? Perhaps most civilizations progress much faster than we have. Maybe once life takes hold, technology snowballs rapidly. Civilizations leap from stone tools to starships in a few thousand years, and then vanish. Or maybe it's the opposite. Maybe most civilizations plateau early. They never grow beyond basic agriculture or early industry. They stabilize and stay there for eons. In either case, our trajectory is unusual. We're not just a blink in a cosmic time. We're on a peculiar schedule. Like showing up to a party 12 hours early with a packet of crisps, wondering why nobody else has arrived yet. That could mean we're out of sync with everyone else. Either too early, too late, or moving at a speed most life never reaches. Now let's zoom in on the intelligence question itself. We often assume intelligence is the inevitable outcome of evolution. That brains like ours are a natural pinnacle. But there's no rule saying that's true. Look at Earth. For hundreds of millions of years, dinosaurs ruled without ever inventing mathematics. Sharks, crocodiles, jellyfish. They are evolutionary success stories, perfectly adapted, unchanged for ages. Intelligence in humans' sense isn't common. It's not even particularly stable. Our brains are costly to run. They burn huge amounts of energy. They make us fragile, anxious, prone to stress. From the evolutionary perspective, high intelligence could be a fluke. An odd detour that usually doesn't happen. In fact, there is a very good argument that our intelligence is maladaptive. Yes, it helps us dominate ecosystems, but it also drives us into wars, environmental collapse, and self-destruct. Other species might thrive precisely because they don't overthink. So maybe most life never produces tall-building, self-aware creatures. Maybe intelligence as we define it is vanishingly rare. In that case, the paradox flips again. So what if we're not just unusual? but dangerous. There's another unsettling angle. What if being unusual isn't just odd, it's threatening? From our point of view, broadcasting radio waves and building rockets is progress. But imagine another civilization watching us. They see a species that went from horse-drawn carts to nuclear weapons in under a century. From rockets to global communication networks almost overnight. To them, that might look unstable, a dangerous outlier, a species evolving too quickly for its own good. If most civilizations develop slowly and carefully, then Earth might resemble a wildfire, bright, loud, spreading fast, but also unlikely to last or likely to burn itself out. This could be another reason for the silence. Maybe others do notice us, but choose to avoid contact, not because they're indifferent, but because they see us as risky. We'd do the same if we were watching animals in the wild, and one of them suddenly started building flamethrowers. We would step back. From this perspective, the paradox isn't where are they, it's why would they want to talk to us? So let's talk about the cosmic perspective. Take a step back and imagine the galaxy from above. Not from Earth's point of view, but from a hypothetical alien civilization's point of view. Picture them looking across the Milky Way with technology far beyond ours. They scan thousands of stars, billions of planets. And what do they see? Mostly silence. Planets with bacteria, worlds with lush ecosystems that never spark tool use. Maybe some clever animals, but clever in a way dolphins or cows are clever. Complex, fascinating, but not civilization building. And then there's this one little odd planet that lights up. A thin film of life covers its surface. And that life builds telescopes, launches satellites, sends probes into voids, and most oddly of all, it floods the galaxy with noise. Radio waves, radar, television signals, GPS. From that vantage point, humanity wouldn't look like the norm, we'd look like the anomaly, the oddball experiment, a planet where something improbable happened. That perspective changes the paradox entirely. The silence isn't strange, we are. And if that's true, then there is a responsibility. Think about it. If intelligent, self-aware, tool-building life is incredibly rare, then we might carry the only spark of consciousness. Possibly for light years, possibly for the entire universe. That's both exhilarating and terrifying. Exhilarating because it makes us special. Not just locally, but cosmically. Terrifying because it means if we squander it, that spark could go out for good. Imagine if every other planet is locked at the microbial level. Life thrives but never wonders, never builds, never dreams of stars. In that case, Earth becomes something more than home. It becomes the universe's only experiment in meaning. That flips the Fermi Paradox from a question about aliens into a mirror held up to ourselves. Usually, this paradox is depressing. It makes us feel small, lonely, cut off in an empty universe. But if the issue is that we're unusual, the mirror flips. The silence becomes a sign that we're extraordinary, that consciousness is fragile, rare and precious. It's like walking into a library where every book is blank except one. And that book is us. Flawed, scribbled, full of typos and mistakes like this presentation. But still the only story written down. The danger is in forgetting that uniqueness. And remembering that we're not invincible. Being rare doesn't guarantee our survival. In fact, it might mean we're fragile by default. The paradox, then, isn't just about wondering where the aliens are. It's about asking whether we can handle being the weird ones. The ones who get too curious, too noisy, too fast. So, the next time someone asks if life is so common, where is everybody? Maybe the better answer is, they're probably out there, but they're not like us. They're quieter, less obsessed with asking questions. And maybe that's why we don't hear them. The silence doesn't mean we're alone. It just means we're different. Different in ways that could make us brilliant pioneers or unstable outliers, or both. And that perspective reshapes the paradox into something less depressing and more humbling. The universe isn't ignoring us. It's just that we're like odd kids yelling questions into the dark while everyone else minds their own business. So let's end with a thought experiment. Imagine you're an alien civilization, 1,000 light years away. You're peaceful, careful, cautious. For millions of years you've kept quiet, thriving on your home world. You scan the stars occasionally, but you never broadcast. Then one day faint signals reach you. Static at first, then patterns, snippets of music, voices, language. The first TV show, the first satellite transmission. There is a theory about what the first transmission that could be heard is, and it's not one I'm going to mention here because it will not do this video any good. You run the data through your computers, and you realise there's another civilization out there. But they're noisy, chaotic. They go from scratchy jazz to nuclear weapons in a blink. From rockets to global communication networks almost overnight. Would you pick up the phone? Or do you wait to see if they burn themselves out first? From that perspective, the Fermi Paradox isn't a puzzle at all. It's a choice. They've noticed us. They just haven't decided whether to answer. So let's bring this video home. The Fermi Paradox is usually framed as a mystery about aliens. The question, where is everybody? Why don't they call? Why don't we see signs of them? But today we flipped it. Maybe the real paradox isn't the absence, but our presence. Maybe we're the weird ones. Biologically improbable, culturally loud, temporarily out of sync. And unusually obsessed with asking questions. That doesn't mean the universe is empty. It just means we're rare. Rare enough that silence is not evidence against life. It might be evidence that we're the outliers, though. And if that's true, then the burden falls on us to survive, to grow, to look after our fragile planet. Because if we are the unusual ones, then losing ourselves would mean losing something the universe may never produce again. The paradox, in the end, isn't about them. It's about us. So maybe the question isn't, where is everybody? Maybe it's, what are we going to do with this impossible, improbable chance? Because if aliens are watching, that's probably what they're asking too. Thank you everyone for being here. This has been Decrypted. I've been Tom. The script is by Ben. The editing, when you see it, will have been by Max. Because nothing is quite what it seems.